Hello guys, it's JohnnyTime and welcome to another smart contract hacking tutorial. Today we're gonna solve together the 7th Damn Vulnerable DeFi updated version 3 challenge CTF, which is the compromised challenge. Now this is the updated version with the new code base, the version 3 2023. So this is the most updated solution you can find online. So I'm so excited. So without further ado, let's get started with the walkthrough. So this is the 7th Damn Vulnerable DeFi Challenge version 3 compromise, and while poking around the web service of one of the most popular DeFi projects in the space, you get somewhat strange response from their server, and here is a snippet. So this exercise is like, we have a bit of like Web 2 security kinda. This is like a HTTP response with code 200 OK that you got from a web server, and we got some data. We got it from Cloudflare, and we got some kind of data that looks like hexadecimal numbers. Let's read through the exercise, the challenge, and see what we have here. A related on-chain exchange is selling absurdly overpriced collectibles called DVNFT now at 19.99 ETH each. This is super expensive for NFTs, and this exchange is selling them with this price. This price is fetched from an on-chain oracle based on 3 trusted reporters, and we have their addresses, the short version of their addresses. Starting with just 0.1 ETH in balance, pass the challenge by obtaining all ETH available in the exchange. So this exercise is regarding NFTs exchange and Oracle, on-chain Oracle that reports the NFT price, and we need to drain all the money from the exchange starting with 0.1 ETH. So the first thing I want to do is jump into the smart contract as always and see how they look like. So we're gonna go through compromised, and here we have 3 smart contracts: Exchange, Trustful Oracle, and Trustful Oracle Initializer. Let's start with the Exchange, which is the contract that we need somehow to basically manipulate. So we need to understand how it determines the prices and how we can somehow steal the money from this exchange. We see that it's updated Solidity version, kinda 0.8. We use address reentry guard by OpenZeppelin, and we import the whole Trustful Oracles contract and Damn Valuable NFT contract, which is this one. So it's just a simple ERC721 by OpenZeppelin with safe mint function, which is controlled by the minter rule. Now, bear in mind that when you're dealing with safe mint, you have a re-entry risk if you don't follow the checks effects interactions, because SafeMint makes a callback to the receiver of the NFT. Now, if you're not sure about what are re-entry attacks and ERC721 callbacks, and you want to solidify and enhance your skills and foundation regarding smart contract hacking, please check out the Smart Contract Hacking course, where we're going to cover so many interesting topics regarding smart contract security. And every chapter obviously comes with hands-on exercises. So in reentry, you're going to hack also NFT contracts with reentry callbacks. And we also have obviously Oracle and DAO and governance and on-chain oracles, off-chain oracles. Everything is included with a many exercise, very hands-on course with guest lectures with the best teachers and professionals from the industry. You also get access to an amazing exclusive Discord community to share your journey with other students and make connections. And you're also going to get an official certificate that increase your chance to get your first job as smart contract auditor. If this is something that you might be interested in, check out the discount link, limited time discount, in the description below. Going back to our exchange, we have here the token and the oracle, and we define here some errors: invalid payment, seller not owner, transfer not approved, and not enough funds. We raise 2 events when someone buy a token or sell a token, and in the constructor, we do few things. We receive the oracle address, right? So this is the trustful Oracle address. It should be a smart contract that implements this trustful Oracle interface that we imported over here. And we deployed the new NFT contract. So the owner of the damn valuable NFT contract is going to be the exchange, and we re-announce the ownership. So basically, we don't have an owner to this one, but we grant the role of the minter. So we initialize the owner over here in the constructor of the NFT, but we re-announce it right after. So there is no owner for this contract, but we still get the minter role, which means that the exchange can initiate the safe mint function and basically mint new NFTs. Now here, let's just fold the function with command K0. Yep. Now we fold the functions. Now we can see the overview, and we can see that we have only buy one, sell one, and fallback receive default function. So buy one is a payable function with non-reentered modifier to protect it. And let's unfold everything. And this is a function to buy NFT. We need to send ETH to the function. That's why it's payable. And it cannot be zero. So we cannot buy NFTs with 0 ETH. The price can never be 0 because it will revert with invalid payment. Now, how it determines the price? It uses the Oracle smart contract and the get median price function. It sends the symbol of the token, and it makes sure that the price is greater than the message value. By the way, if you see something like this in audit contest, it's an issue because audit issue, the user can send more money than the price, and this ETH will be stuck forever in the smart contract. So instead of greater, price should be greater than message values, price should be exactly message value, so there won't be extra ETH that the user will pay and will be stuck in the contract. So ETH may be stuck in the contract, need to change to equal instead of greater than message value, right? So it's a valid, usually medium issue in auditing contest, but in that case, it's not going to help us much. Now, we use the safe mint function to mint the user the token, obviously only if he paid the correct price. And we use the unchecked block and send the value, right? We basically send the chain. So if the user paid too much ETH, then we send him back the ETH. So we send the message value minus the price, which basically means that I just made a mistake here. And this is not a valid issue because we basically pay back the change to the user. So in case he mistakenly sent too much ETH, we just pay him the change. So it's not an issue, my mistake. And then we emit an event that token was both. Obviously, we have also a sell function where someone can sell back the NFT to the exchange. We make sure that the message sender, the one who called the function, is the owner of this ID, this token ID that is trying to sell, or we revert that is not the owner. We also make sure that he approved the smart contract to spend this NFT token. If not, we won't be able to call the transfer from function. But before we transfer the actual NFT and burn it, right, as you can see over here, first we check the current price by, again, fetching the price from the Oracle smart contract. And we make sure that we have this price in the balance of this exchange smart contract, or we revert with not enough funds. Now, after we did those checks, we check the price, we get a token from the user with the transfer form, burn it, and then send the value, send the ETH, basically the price, to the seller, to the message sender, and emit an event. So this is pretty simple exchange contract. Now, we don't have too much things to do here because maybe if you would think that there should be a reentrancy here, yes, there is a callback, but we see that the function follows the checkFX interactions, and also it has non-entrant modifier, both of them. So I don't see any possibility for reentrancy here. That's why we're going to explore the Trustful Oracle and Trustful Oracle Initializer contracts to see if we can find some vulnerabilities there, because we know that the exchange is utilizing this contract to get the price for the NFT. So the Trustful Oracle Initializer, it simply just imports the Oracle contract, then it has a state variable of the Oracle, and then it deploys, okay, It deploys the Oracle. It's just a deployer and initializer, like a factory contract with the sources. Okay, it receives the sources, the symbols, and the initial prices. So it deploys the Oracle, and then it's called the setup initial prices to set up the prices and emits an event. So the juicy part is actually in the trustful Oracle contract. We want to go there, and let's see what happens here. So we use access control and some kind of sorting library from Solidity, and this is going to be access control enumerable. The minimum amount of Oracle sources, the trustful sources where we trust to report the price for the NFT, is 1. So there should be at least one source. Now we have two roles in this access control contract, which one is the trusted source role and initializer role. We will see later what these roles are used for. Now here we have a mapping that's called prices by source, and we map between source, the address of the source that report the prices, to the symbol. So it's mapping inside mapping to the symbol, and for the symbol there is also the price. So a source can report multiple symbols and multiple prices. This is how this contract works. And we have one error, not enough sources, and event for updated prices. This is the constructor that we saw earlier on here, basically called once we deploy the contract with the sources and with true. Now let's see what is these parameters. So sources is just array of addresses, and this boolean is whether to enable initialization or not. This is we sent true. And we make sure that we have at least one source. And now what we're gonna do, we're gonna just set up for every address that was passed to us through the sources array, we're gonna basically set up the role of the trusted sources role. So we are setting up the sources, simply as that. Now, if this flag was on, if this boolean is true, then we set up the message sender as the initializer role, which means that he can call later on the setup initial prices, because it's going to be protected by the initializer role. And then he can call it with sources, symbols, and prices, 3 arrays: address array, string array, and uint256. Now, obviously, we make sure that the array lengths are the same, but we don't check that the length is 0, which is an issue in my opinion. We need to check also that the array length is greater than 0. And we iterate through the sources array. So it's the same because the lengths are the same as the whole array. And we set the price for every single source, which is the price that we received here. So we can initialize already the prices through this initializer. And right after, we remove the role of the initializer role, so this function won't be able to be executed again. We can call it only once because right after it's done, we remove the initializer role from the message sender. This is interesting. Now, we saw that the exchange is using the get median price to receive the price for the NFT. So let's see what this function does. It does. Get median price is receiving a symbol and then using the compute median price. I assume it's an internal function, and we can just go to this function and let's see what it actually does, how it actually determines the NFT price. First, it gets all prices for symbols. So this is this function, which basically returns an array of prices, of integers, uints. So it gets all the sources, gets roll member count of the sources. So we have how many sources we have, it gets all of them. Let's see how many sources we have, even though it described here that we have, I guess, 3 sources, 3 trusted sources. We can also go to the test file and basically verify that this is actually the case. So compromise.challenge, and we can see that we have here 3 sources. We see also these initial constants that were said, like 1999 ETH in the exchange. The price is 1999. We have only 0.1 ETH in balance because it's 17 decimals. And we see the trusted source initial balance, which is 2 ETH. And let's see what happens here. Yeah, we basically... it happens over here. We deploy the Oracle, the initializer, and then we set it up with 3 sources, 3 symbols, and 3 prices, the same prices, right? Only 1999 ETH. So now we know that it's being initialized with 3 sources, so it's gonna be here 3, and we're gonna iterate here 3 times and just get the price by source. So we have here the price by source mapping that we saw earlier on, and every source can report the price, and we retrieve all the price that all the sources reported. Now, how they report the price? They simply gonna call this one post price. This is an external function that is protected by the trusted source role. Only the trusted source can call this function, and they can set the price for the symbol. So if someone compromises this private key of the source, he can call the post price function in order to set the price. Now, once we got all the prices, we go back to the median function, the compute median price, and let's see how it works. First, it sorts the prices, okay? So it sorts the prices, so if we had 1, 2, 3, it will be sorted in the array. We use this kind of insertion source, which is simply just a sorting algorithm, which you can read about in Wikipedia. And it's gonna sort it from the smaller number to the bigger one. Now, once we got this sorting algorithm done, and now the prices array is sorted, if the length of the prices array is even, you see, modulo from 2 equals 0, which means that we have even number of sources. This is how we determine the price. If it's uneven, this is how we determine the price. So in our case, it's uneven. It's odd, it's not even, which means that we're gonna go here. And in that case, let's say we had 3 sources, we're gonna just go the price in the middle because it's sorted. So we take the median price, the price in the middle, the element in ID in index number 1. If it's not the case, if it's even sources, even amount of sources, then we get the edges of the prices, left price and right price. As you can see, this is the left price, the length -1. So we basically get the middle prices, and we do some kind of average, right? So we do left price plus right price divided by 2. But this is not our case because we have 3 sources, which means it's odd. So we just take the item in the middle. After it's sorted, we just take the price in the middle. So usually when I have these kind of complex systems, I like to draw diagrams with Excalibur, and here I drew some diagrams for you to help it understand it better. So we have the exchange, and the user can either buy or sell NFT to the exchange, and the exchange is using the oracle to determine the price. The way he does that is calling the get median price function, and the prices are basically affected by the post price external function that we saw over here. This is the post price that only those 3 trustful sources can call and update the price, okay? And the way that this get median price works is using this compute median price, which gets the prices from all the sources. So it could be 3, 4, 5. In our case, it's 3. Then it sorts it from smaller to the biggest number. Then if it's uneven sources, it's going to get the item in the middle, which this is the example. So if we have 1, 2, 3 prices, it's just going to sort it from small to big and get the item in the middle. So it's going to be 7. This is going to be the price of the NFT. And if it's even sources, it's going to be the average of, not the edges, actually, it's the middle numbers, because we don't have like odd number in the middle. So we take these 2, this is the algorithm, and then we do 13 plus 25 divided by 2, which will give us 19. So these are the 2 cases if it's odd or even, and in our case, it's odd. So this is the way the algorithm works. Now that we understand how basically the protocol works, we understand that in order to manipulate the price, the oracle price of the NFT, we will have somehow to compromise these trustful sources. Now, because we have 3 trustful sources, compromising one won't be enough. Because let's say we compromise this one and we pause the price to be 0.0001, like very low price. It won't be enough because still the price will be the one in the middle, which means that we need to compromise at least 2 sources in order to affect these 2 prices. So basically it could be the same or it could be like the different price, but if we want really to affect the price of the NFT, then we will have to compromise at least 2 sources to basically manipulate the algorithm. the median price algorithm. So let's see what kind of ways we can do to basically compromise maybe those sources and manipulate the oracle. So we got a small hint here, and if you remember in the beginning of the exercise, we got this hint that we received this message from a web service that is related to this exchange or DeFi protocol, and this data is interesting. Maybe it's somehow related to the trustful sources, private keys, or it will give us some hint to proceed, because we actually got stuck. We don't have some kind of free entry, and we need to control these accounts in order to actually change the prices. And this, for me, if you come from traditional cybersecurity, it looks like hexadecimal characters. So I will first try to convert it to some kind of string. So what I'm going to do is going to search in Google for something like hex to text or hex to string, and just go to the first result that I got here, and I will just try to convert it. Let's go here and take this whole value and try it from hex to text. Let's see what we get. Let's hope and cross our fingers. It didn't work. Maybe it expects a different format, or let's just try to use another conversion tool. Let's try the second one. Yeah, like this one. So hex to text, I'm gonna remove the break line and convert, and this looks more like it, right? So everyone basically represent a ASCII character. So ASCII is basically every character in your keyboards can be presented by a binary number that can be converted to hexadecimal number. We won't get in depth. If you want to get in depth into all these kind of things, we cover them in the smart contract hacking course. But this string, if you are also familiar with traditional cybersecurity or with a smart contract hacking course, it looks like base 64 encoding, right? It's not encryption, it's not a hash, but it looks like base 64. And I'm gonna try my luck here with base 64 decoder. I'm gonna decode this string from base 64 encoding to a normal text, and let's try. And that's more like it. This looks like a private key, right? It starts from 0x and it has the right amount of length. So I assume this is the private key for either the first or the second resource. So I'm gonna go back to let's go to the JavaScript file, and let's already store it in a variable. So I'll do something like const p-key1, private key 1 equals this thing. I assume it's private key. It looks like a private key, but we will see later. Now we're gonna do the same for the other numbers. So I will convert it from hex to string first. We get this value, and then from string, from base 64 to private key, and there we go. Const p-key2 equals this value. And now it seems like we got two private keys, which probably gonna be the ones that control two of these sources. We are not sure, but we can check it actually, because you can derive the public key from the private key. But I will just try my chances here. So let's see what we want to do. Our algorithm is gonna be update the buy price, update the price, just update the price. But before we do that, let's just write here. So this is hex to a string to base 64 decoding. I would say ASCII because it's ASCII characters to base 64 decode. So it will be clear how we got these private keys. Now that we know how it works, we want to make our pseudocode. So first we want to set the price, to very low amount, right? Because we want to buy the NFTs from the exchange in a very cheap price. So we're gonna set it to 1 WE, just very low amount. And then we want and buy 1 NFT. So we're gonna buy 1 NFT in a very, very cheap price. We're gonna set it and buy 1 NFT. Now, once we have the NFT, we want to sell it to the exchange with a very ridiculous high price. And actually, we want to sell it with 99 ETH because we want to drain all the ETH from the exchange. So we're going to set the price to 99 ETH. Actually, we need to drain it completely because if we see here that the state should be that the exchange should be 0. So if we bought it in 1 week, it needs to be 99 ETH plus 1 week, to make sure that the exchange has 0 ETH in balance over here, right? And then we need to sell this one NFT back to the exchange. Now, let's see what else we need in the state. So another thing we need to do, we need to get the money to the player account, obviously, and we need not to own any NFTs. It's not going to be a problem because we're going to sell it back to the exchange, and the price shouldn't be changed. So which means that we need to revert the price, restore it to the initial price. So I will add here set original price. Now we know our attack plan, our exploit plan, and let's try and start implementing it. So now we already have the private keys. Let's try to get the signer object from this private keys. So it will be signer1. We'll create a new Ethers wallet object, and we will give it first the private key number 1, and we will give it the Ethers provider object, right? This is all in the Ethers documentation. You can check it out, how to create a signer from a private key. And I'm going to do the same for signer 2 with private key 2. Now that we have these two signers, we assume that these are two of the trusted sources, which means that we can update the price using these two signers. So I will do await oracle dot connect and signer1, and we want to call the post price function. Now, what is the function? What is it going to receive? The post price function. Let's see, post price symbol and the new price. So the symbol, we already have the symbol. It's DVNFT. So we're just gonna copy it and we're gonna send here the symbol, and the price is just going to be one way, right? We want it to be super cheap, and we're going to do the same with the second signer because we already know that we need to update two trusted sources in order to get the right median price. Both of them need to be very, very low. Now, once we updated the price, obviously, now the price for NFT will be 1 week, hopefully, not obviously, and this is our time to buy some NFTs. So await exchange.connect. We're going to buy it from the player account, and we're just going to call the function buy 1, right? So we need to pass this function the ETH, right? So it's a payable function. We need to make sure that our message value is greater than the price or equal the price. So we're gonna just send here value, and it will be just 1. So we are sending 1 way and basically try to buy 1 NFT. Now we need to set the price to very, very high price and sell the NFT back to the exchange. So I'm just gonna call these functions again, this post price, and this time it's gonna be this initial NFT price, right? It's gonna be very high, 99 ETH, plus big int, because I need to convert it to a very big number, and 1 way, right? Because we want to make sure that in one sell transaction, we're able to drain all the ETH from the exchange, which is the initial 99 ETH plus this 1 way, or this condition will not met and we will not be able to complete the challenge. And now we want to sell 1, okay? So I'm gonna call this exchange with sell 1. This time we don't need to send ETH because we're sending NFT, but we do need to send the token ID. And I assume that the token ID is just the first token, because I don't know if like someone minted tokens and bought with this ridiculous price those NFTs, probably no. So there wasn't like buy transaction. So it's going to be the first token, which means that the token ID is going to be 1. Now we need to revert and restore the price to the original price. So I'm just going to copy these 2 lines of code and make sure that the price eventually is going to be the same initial price. So it's without this big int, without this 1 way, just the initial NFT price. And I think our exploit looks good. We don't need to implement any smart contracts. It just, we compromised those private keys. We're able to manipulate the Oracle price in order to trick the exchange and drain the ETH from it. So again, we'll do a quick overview. We got these 2 private keys and 2 signers. We updated the price to very low price, 1 ETH. And then we bought NFT with a very small price from the exchange because we are broke. Now, we posted this new price from the same signers, which is all the balance of the exchange, the initial balance. It's the same as the initial NFT, right? It's the same number, plus this 1 week that we gave it through this buy transaction earlier on. And we're gonna sell this token ID back to the exchange, which is highly ridiculous price to get all the ETH from the exchange. Eventually, we're gonna set back to the original price, so no one will suspect that we did anything, or even though the transactions are gonna be on chain probably. And that should be enough. And this is the money time, right, guys? This is the time to run the test, yarn compromised, and see if we're probably gonna have bugs. So cross the fingers. And we failed, guys. We failed. Okay, invalid token ID. So I guess this is not one. Maybe it's 0. Maybe it starts from 0. We can actually check it and go here and see how. Yeah, the token ID counter starts from 0, right? Because this is the default number for UN256. So the first token ID is going to be 0. Now I assume this is 0. Let's try again with 0. So let's run the code again. Yarn compromise. Cross your fingers, guys. And we failed again. Transfer not approved. Obviously, we are trying to sell the NFT, but we did not approve the exchange to spend this token. Therefore, we need to call the NFT contract, NFT token dot connect. We are connecting sending transaction from the player, and we call the approve function, and we're gonna approve the address of the exchange to spend token number 0. So basically, no, it's not gonna be like this. This is in Solidity. It's gonna be exchange.address. Okay. So we are approving the exchange to spend this token, so we will be able to sell it, and he can use the transfer from function. Now let's try again, and this time, third time, it's gonna work, right? We made it, guys. You completed the 7th challenge in Damn Vulnerable DeFi. You learn about NFTs exchange, about oracles, off-chain oracles, and how you can exploit them, private key compromise, hexadecimal to ASCII, to base64 decoding. You learned so much, and this is amazing. Now, if you like this content, make sure to smash the like button and subscribe to the channel for more videos, smart contract hacking and auditing. And if you have any questions, feel free to ask them in the comments below or DM me on Twitter, on LinkedIn, wherever you want. I'm available for you. Thank you so much, and I will see you in the next time. Bye.